All right, so let's move on to the next free response question. We have a shopper pushing the shopping cart once again. Before I even look at this problem, let's draw a free body diagram. So we're going to have weight, we're going to have normal. Let's assume that the applied force goes down like that. Well, not assume, that's what they show us. And we know there's friction acting on the system. So that means we're going to have FAX and we're going to have an FAY also pointing downwards. So we need to set up equations in the x and in the y. Okay. So let's get the normal force by setting up our equation in the y. So we have the normal pointing up, the weight pointing down, and the applied force pointing down, and the effect is that those all cancel. So I have the normal equals the weight plus the downward component of the applied force. So that's going to be 40 times 9.8 plus FAY, which is going to be 71 times the sine of 35 degrees. So when we go ahead and calculate that, the answer we'll get is 433 newtons. Now let's continue in a similar vein. The coefficient of kinetic friction between the cart and floor is 0.3, so we want to get the kinetic friction. So we're going to set up the equation in the x direction. Now, I will not, so to get the kinetic friction force, we know that the friction is going to be mu times the normal force. And that's going to be 0.3 times the normal force which we got before, which is 433 newtons. And when we calculate that number, we're going to end up getting 130 newtons. Now, continuing in that vein, if the coefficient of friction between the car and the floor is 0.3, what is the acceleration of the cart? So we need to have Fx minus F equals ma. And to get Fx, I'm going to be using Fx equals 71 times the cosine of 35. So let's go ahead and get that number, which is about 58 newtons. And we know that here, the friction force, I don't know if this is a possible problem to do. Let me make absolutely sure that I've got this right. Because when I'm looking at these numbers here, if I've got 71 cosine 35, that is not going to work out for me. So I do not know where we got this number from, but this problem is clearly flawed. This is impossible. Why is it impossible? Because I have a friction force of 130 newtons, and I have an applied force of 58 newtons.